Hi, I'm Brian Dipert, Editor-in-Chief of the Embedded Vision Alliance, and with me today is John Morse, Senior Market Analyst with IMS Research. Hi, John.
Yeah, hi.
Good. Thanks for joining us today. This is the third in a planned series of video interviews with various IMS Research market analysts, covering various application areas in which embedded vision has a role today and is anticipated to have a larger role in the future. At the beginning of this year, I spoke with John Cropley, who covers video surveillance systems for IMS Research. A couple of months ago, I spoke with Helena Perslow, who covers advanced automotive driver assistance systems. And John is IMS Research's machine vision expert. An area in which actually computer vision has had a significant role in the past and is now transitioning from a PC-based system design to a more embedded vision approach. So, John, before we dive into your specific area of market focus, I understand there have been some recent ownership changes at IMS Research, and I'm fairly up to speed on them, but maybe our audience isn't. So could you speak on that for a few minutes?
Yes, of course. Back in March this year, IMS Research was acquired by a company called IHS, who are based in Englewood, Colorado. They're a large company, $1.6 billion, I believe, in that order. And they are a large market intelligence and information company. So we're now in the process of being integrated into that company. Although in the past they haven't had a factory automation hasn't been a specialist area for them. And so our group, which concentrates on that area, is not being affected to a large degree at the moment, and we're just operating as we did. So for the moment, definitely no change there, and we'll carry on doing the same reports that we're doing.
Okay, thanks, John. Could you give us a bit of a background on yourself, both at IMS Research and prior, generally and specifically in the area of machine vision?
Yes, of course. I did a degree in physics and electronics, and I was involved in the radio industry, working for a company called Marconi. I then got involved after that in semiconductor physics and the automotive industry, and ended up in factory automation, working for Mitsubishi Electric, introducing their range of programmable controllers into the UK market, and then with a similar kind of position with Allen Bradley, which is now Rockwell Automation. And from that, got involved in a few things, but ended up here at IMS Research 10 years ago. So I've been in factory automation generally and machine vision applications for a few years now, and so can offer some experience there.
Okay. So machine vision is a pretty broad product and technology category. Can you speak to the areas of machine vision that you specifically cover in your analysis and in your reports, and maybe also talk a little bit about the evolution of machine vision from its PC-based heritage to now increasingly being embedded vision from an implementation standpoint?
Yes, certainly. Well, we concentrate predominantly on machine vision in factory automation and process automation, so industrial automation in general. So we're very focused on that area. The people we talk to are all manufacturers. We don't account in our reports for companies such as systems integrators and distributors, largely because of the risk of double counting. So we concentrate on the manufacturers. So it's manufacturers that manufacture and supply to, design for and supply to factory automation and process automation. The evolution, well, it's changed dramatically from analog cameras. The first systems I got involved with Allen Bradley were the size of this desk, quite complex systems, very expensive, to now where literally products that you fit in your hand, tiny products, this big, this cube, little cubes this size can do very substantial machine vision and good quality machine vision. There's always room, of course, for the very sophisticated cameras and systems, but it's changing, and of course the development of semiconductors, suitable semiconductors and processors has been largely instrumental in doing this. The actual lenses themselves haven't changed very much, but the electronics behind them have changed significantly and are continuing to change.
Okay. How do you segment the machine vision market into various areas from a coverage standpoint?
Well, the majority of what we cover is machine vision hardware. So we look at machine vision hardware, machine vision software, and then we look at services and accessories. Now, these are only services and accessories that are supplied by manufacturers, as I mentioned before. Software is only software which is designed specifically for machine vision applications and sold as a product in its own right, rather than as a part of a camera. I mean, many cameras you buy will come with a CD or some kind of program that will enable you to set it up. But there are companies that make specific machine vision software packages. But something in the order of 75% of the market is hardware, which we split into cameras, smart cameras, frame grabbers, lenses, etc., and lighting. So that's how we segment the market.
Okay. How about from a region by region basis? Are there significant differences in various areas of the world?
Well, there are, yes. I mean, roughly speaking, between EMEA, Americas, and Asia Pacific, you're talking about something in the order of, in revenue terms, 30%, 30%, and 40%. But when it comes to Asia Pacific, something around half of the market is in Japan alone. As everyone is very aware, Japan has a very sophisticated manufacturing base and has had a number of decades. And they've taken machine vision to heart. So they count for a large chunk of the market. However, that's changing, particularly because of China, who's having to develop their efficiency in their manufacturing, and countries such as South Korea and Taiwan, particularly, are becoming very avid users of machine vision. So, yeah, the scene is changing all the time.
Okay. So as we talked about in the early days, these were relatively dumb. You mentioned analog cameras, for example, but from a built-in intelligence standpoint, relatively unintelligent cameras tethered to pretty high power, high performance, high-end PC servers. And now the cameras are becoming smart in and of themselves. Can you speak a bit more about that transition, and about what cameras are increasingly looking like?
Well, they're changing significantly. From analog cameras to the earliest digital cameras, which were quite large, more and more more and more processing is actually being built into the cameras themselves. So you've now got what are called smart cameras, where you don't need a PC, whereas you can point the camera straight at the device and take the output straight into a function, rather than actually have to go through a frame grabber board. You've then got compact vision systems, which are similar kind of thing, where the camera is separate, not built into the unit. So you can have 2 or 3 cameras going into a box, which does all the processing without the need of a separate PC. But the market is changing from that point of view, because you're getting what we're calling smart sensors, which are what used to be optical sensors, but have now become so clever they're encroaching on the bottom end of the smart camera market. And also, of course, smart camera makers are making smaller ones as well to meet them somewhere in the middle. So the line between smartness and a standard camera, it becomes fluffier all the time. And, by definition, we have to put things in boxes. It's become sometimes a little difficult to actually do the classification. But there are some lines we can draw. So we have to be very careful how we define the products.
Okay. How about the image sensors inside the cameras? How have those evolved over time, and how do you anticipate that continuing to evolve in the future?
Yes, indeed. Well, traditionally, CCDs have been used, charge coupled devices have been used ostensibly throughout machine vision cameras, but that's changing. CMOS technology has come leaps and bounds on the sensor side, They've always been fast, but the quality has not always been up to CCDs. But the quality is now is a competitor now to CCDs. There will always be the need for them because of the dynamic range for CCD is greater. But CMOS is a cheaper technology to manufacture. So we're definitely seeing a move towards CCDs, and that will, I'm sure, that will continue. Certainly, the indications are that will continue further on. So those are the two principal technologies that are used.
Okay. How about the communication technologies that are used to tether cameras to each other, to the local area network, to other devices on the LAN, and as well as to the internet? How has that evolved over time?
Well, they have their own language, really, when it comes to communication, because they need speed. They tend to generate very large files, particularly in color, and they need fast speed. Simply, especially if you're on a line or a bottling line, where you're checking labels or something, they're whizzing by faster than you can see them with the naked eye. Excuse me. So. The first digital technology that really caught the imagination was Firewire. And Firewire came along, which was designed for video applications, but the machine vision people picked that up very quickly because the early versions ran at 400 megs. Current versions are 2 or 3 times that speed of Firewire. But other technologies came on board. There's Camera Link, which obviously the name suggests is designed specifically for machine vision applications. And also Ethernet is now Ethernet and USB, and there's a GigE Vision, and there's now USB 3 Vision. Now these are standard versions of the technology, but with some extra functionality, camera control, zoom lens control, this kind of thing. So it's changed dramatically. Ethernet is definitely growing the way things are going. Gigabit Ethernet is growing fast, but the simplicity of things like USB 3 and even Firewire they're easier to use. So there's very much a number of manufacturers tend to specialize in particular communication technologies, but these can always be patched into a standard network. Right. But they do tend to be a little bit specialist.
What are the primary industries that use machine vision? And do you see up-and-comers that may not be large today but may become dominant in the future?
Well, traditionally, we tend to find the two main industries are automotive for machine vision, simply because of the size of it, but also semiconductor is a very important industry for machine vision. Inspecting semiconductor devices is not easy, simply because they're so small, and also they manufacture at very high speed. And so semiconductor is a very important industry, and has taken machine vision to heart in a big way. Other industries that, the food industry uses it, particularly the high quality color cameras, where they can check the whether some cookie has been cooked properly by checking the color using specialist cameras and high quality color cameras. But in anything that involves a lot of human eye inspection is a good industry, or is important to machine vision. The other area, of course, is robot control. More and more companies are specializing in taking machine vision cameras to teach robots where to go look for things and pick them up. So that's probably the second area which is growing for the use of machine vision.
Okay. So we talked about the intelligence inside a camera. We talked about the image sensor that is used to capture the images within the camera. How about the lighting systems? That seems to be a pretty important thing in terms of ensuring accuracy of results.
It certainly does. It's extremely important. And traditionally, in the past, very often, especially with simple camera systems, people devise their own lighting systems, even using incandescent lamps, fluorescent lamps. But the quality of the cameras and the speed at which things operate these days is not good enough, and LEDs have really taken the market over now. Something like 98, 97, 98% of the market uses LEDs. They're very bright these days. They don't suffer from flicker like a fluorescent light would do. And where the lighting is positioned makes a great difference as to how the camera sees the object. So if it can be backlit, if you're particularly looking for a profile shape, or it can be front lit or side lit. If it's front lit, you can perhaps it's easier to see it if you're looking for the presence or the absence of a component or a hole that's been drilled. So lighting is extremely important, and what's also important is that manufacturers need to be able to replace them if they break or when they wear out. Even LEDs do wear out. They need to be able to use standard products. So there's a lot of companies out there which manufacture a standard range of lighting, and it's a growing sector of the market. It's moving away from the DIY and moving towards standard products.
Okay, thank you. So speaking of growing portions of markets and markets more generally, how big do you size the machine vision market today, and how do you see it growing over time?
Well, at the moment, we would say in 2011, I would put the value of the market from a manufacturer's standpoint, from something in the order of $3 billion US worldwide. And I see that growing by 2016. I would be very surprised if we estimate that to be less than in the order of $4 billion. So it's substantial growth, and the growth is by and large greater than the overall growth of factory automation in general. So it's certainly one of the growing sectors of the market. There's no question about it.
Okay. So we've covered a lot of ground today. If you could, how would you summarize the prospects for the machine vision industry in general, as well as for the embedded vision aspect of that industry?
The prospects are very, very good indeed, especially from an embedded vision point of view. Cameras are getting smaller, frame grabbers are becoming more and more sophisticated where they're required. And so it's driven, one of the big drivers is the size of semiconductor devices, the size and the capability and the functionality of semiconductor devices, and how compact you can make that. So if you had to summarise in one word, I would put good, and in two words, very good. So it's got a long way to go, and we will be monitoring that market on an annual basis from now on, watching it grow.
Okay. Is there anything else that we haven't covered today that you'd like to focus in on and emphasize in this space?
Oh, not really. I think the important thing is machine vision. Although we concentrate on the use of machine vision in factory automation, more and more manufacturers of products capable or built to specification for industry are finding applications outside of, if you like, the traditional factory and plant. And I'm talking things like high quality surveillance, where image quality is beyond or needs to be greater than typical surveillance type cameras. Medical, a lot of medical people are using machine vision for monitoring samples of various items. That's a growing area as well. So there's lots of uses outside the tradition, which machine vision manufacturers are finding applications for, and that will continue. I'm absolutely certain of that. So we're going to see some good growth outside that.
Well, John, I've really enjoyed our talk this morning. Thank you very much. It's been very informative for me, and I'm sure it's also been for the audience. Thank you in the audience for tuning in today. I encourage you, while you're on the website today, to check out the other two IMS Research video interviews that I mentioned at the beginning of this talk with John Cropley and with Helena Perslow. And please come back and revisit the site on a regular basis. We'll have more interviews with other IMS Research analysts, as well as other video and article, technical reference content, downloads, etc., coming up on the site on an ongoing basis. So thank you, John. And thank you, embedded vision industry participants. Take care. Have a good day.